Hello, everyone. Welcome to yet another edition of the Istio community meeting, where we invite our contributors, maintainers, and end users to share their journey with Istio with a wider open source community. I'm Fasila. I'm a maintainer and steering committee member at Istio and a cloud native developer at Ericsson. So I'll be hosting the community meeting this time. So today we have two amazing speakers joining us. One of them is an Istio maintainer, Jeremy Morris from Microsoft. So he's going to talk about one of his latest contributions to Istio for better troubleshooting of Istio ambient mesh. And the second speaker is an Istio user, Bernard from Splunk, who is going to share with us Splunk's journey of Istio and some of their latest innovations in easing Istio configuration. So I will hand over to Jeremy now for a quick self-introduction, and we are excited to learn more from you about the istioctl enhancements for ambient profile.
Thank you. Can you hear me well? Everything's good? Okay. Yeah, so as Fasila said, my name is Jeremy. I'm a senior software engineer at Microsoft. Also, recently been made an Istio maintainer, in part due to a lot of the work that I've done with istioctl and getting that like final push out for ambient beta release. I've been contributing for about a year now. I've been at Microsoft for about a year. Before then, I never really used Istio at all, never operated it, never contributed. I did make one PR a long time ago. I think it was like 2017 or something like that. When I started contributing to Kubernetes, I was just like looking for random CNCF projects. But then I stuck with Kubernetes, and a lot of my career has been spent around like contributing to that space and working on the managed Kubernetes product at DigitalOcean. But when I joined Microsoft, there was an opportunity to work on this project called Istio, still in the same space as Kubernetes, but a little bit different, more networking focused. Admittedly, that's actually one of my weak points. And I like to think of things in like long-term career like prospects. And I know that networking is so valuable. After dealing with bugs in Kubernetes, for example, I learned a lot of the value that exists in actually being good at that. So I figured this was a good opportunity to get better at networking. So I jumped right into the opportunity to work at Microsoft and start contributing. And luckily, Istio is a pretty welcoming community, so it wasn't too bad. So this demo, let's go back, is going to be about or this presentation is really about the istioctl commands that I contributed to, like the reasoning behind them, the experience of contributing. We'll try to go over some examples, time permitting. And also I want to really like empower users and aspiring contributors to provide feedback and continue to like, just be involved with the community. I think that Istio will evolve best with contributors and maintainers collaborating with end users and such. I think that's the best way to build Istio in a way that makes sense for everyone. And I'm also going to go over like a high-level description of ambient and istioctl, with the thinking that the audience might consist of people who are like completely new to these, these buzzwords essentially. And also, we're gonna have information here for the people who are more experienced and are just on the fence of whether or not they should use traditional Istio with sidecars or pop over into ambient. So just to go over some basic terminology, ambient, that's the Istio model where L4 and L7 traffic are now split out into two different components, as opposed to the traditional way of having a sidecar or Envoy proxy existing for every application that would handle the full suite of things. This new model basically breaks out like kind of like a separation of concerns to two different components. This allows for like a better layering model, so that maybe a consumer or user of Istio might just want L4 advantages like MTLS and authorization authentication that you get at the L4 layer. They might just want something like that. They might not need the extra waypoint piece. But if you want to add that in, you can, and then you can add a waypoint into the service mesh independent of the other applications. istioctl, that's just the tool that is used to configure your Istio resources. So that's a command line utility. That's basically the gist of this entire presentation is talking around that actual tool. In Ztunnel Ztunnel is the L4 component of ambient. That's that zero trust tunnel, the MTLS secure communication bit I just mentioned, and waypoint is the L7 component. So that should be a good high level overview of those terms. If you want like more in-depth understanding, there's tons of like great documentation that you can go through to get like a more thorough understanding of how the traffic flows through those different pieces. Now, yeah, so what is ambient? You need to know what the pre-ambient looks like. This is like a good diagram to kind of visualize that. You have this sidecar proxy for every application here, and as you can see, there's no differentiation between L4 and L7. It's all kind of bundled into this Envoy proxy in terms of what gets handled. This is good, but as you can see, when you scale up, there's a potential for this getting pretty resource intensive. If you're having a proxy for every app that you're adding, it can get pretty heavy, right? So here comes ambient. So this is the initial like if you install your ambient profile for Istio, you'll get Ztunnel and CNI, but you won't get waypoint. That's an optional piece. This is just like kind of like vanilla, plain ambient setup. You have the advantage of having MTLS, communication between your services and such. And then Ztunnel is communicating with other Ztunnels over this HTTPS connect tunnel, also known as HBone. That's how that secure zero trust is happening between the Ztunnels. And then, you also have L4 telemetry here as well. Now, if you want to have the more, let me take a sip of water. If you want the more traditional full suite of Istio functionality, you should throw in a waypoint. And waypoint is the L7 piece. That's how you get the HTTP routing, load balancing. You want to do like retries or timeouts and things like that. If you want to have richer authorization policies, that like deal with L7 primitives such as request type or HTTP header, that's what waypoint will allow. So now you have the L4 component, which is Ztunnel, and then you can optionally add in your L7 piece, waypoint. So looking at this, the original diagram, a lot of these commands that I added as part of ambient beta are like convenience kind of things, right? So if you want to do some operations on waypoint or Ztunnel or troubleshoot things, these istioctl commands will make it easier to do so. If you want to modify the YAML and preview the output, if you want to look at Ztunnel's idea of workloads or services to see that the waypoint is matching up as it should be, these are the commands that you would use. So we're going to start with the waypoint side of things. You can name your waypoints now. You can also define or declare the traffic type, and there's a lot of different commands you can do in terms of generating the YAML beforehand. You don't necessarily want to apply YAML in some cases. Maybe you just want to generate the output and then use it with some like CI/CD tool like Flux or something that reads YAML and applies it in a different way. But you also have the ability to apply the YAML directly through istioctl. So with the generate commands, there's default values that get set when you don't pass in a name or a traffic type. So that for value I was talking about earlier, that says what type of traffic is allowed to go through the waypoint. If you leave that out, it's just going to default to service. And the way that this works with the gateway resource is that a label gets added, the waypoint for label, and that is the thing that a controller elsewhere in the code will read to understand what traffic that waypoint should support. So by default, it's going to be service, and by default, the name is going to be waypoint. So if you run istioctl x waypoint, and by the way, X stands for experimental. At the time that 1.22 is released, and you still have access to it, I think it's like 1.22.1 or something like that. It's considered experimental, but in 1.23, you're going to see that waypoint has been promoted to out of it experimental. So you would just do istioctl waypoint. But for now, it's experimental. So we have to have the X there. And then generate, it just prints out the YAML. Now, if we want to generate an example YAML output for a name that we specify and a traffic type, you could do it like this, and you'll also see, again, that the label it's not the default value of service anymore. It's going to get updated to what you pass in, which was workload. And then the name is test waypoint. Thought I added another example, but if you also add in a traffic type that's not valid, there's only 4 options: all, workload, service, or none. There's some checking that happens on behind the scenes in istioctl that basically checks a set to see if the value passed in is included in that set. If it's not, it's going to return an error and say like, hey, foo bar is not a valid traffic type. Please use one of these 4. So that's another reason why, istioctl might be convenient. If you go ahead and just, create the YAML manually and try to add this yourself, I'm not sure how that error flow looks, but it might not be as immediate as just checking with istioctl real quick and verifying it. Now we can go on to the enroll namespace command. That is convenient because say you want to get, give all your pods and services access to that waypoint in the namespace. One option is to go to every single pod and service and label it manually by using like kubectl label, and then do that for each of those objects within the namespace. Or you can kind of do it like wholesale or just do all the ones in the namespace. And that's pretty convenient. If you have like hundreds of pods or something like that, you might not want to do that manually, right? So you can just, well, let's talk through the steps. First, if we look at the default namespace, that's what we're working in right now, and you will not see a use waypoint value. That's the thing you want to look for when you're labeling these things in terms of what it should use, right? So we talked about waypoint 4. That's the traffic type value that gets specified for the waypoint, what traffic is allowed to go through the waypoint. Use waypoint is the label that you put on the resource to tell it what waypoint to use. So if you did it for a pod, it would still be the label istio.io/use waypoint, and then you would specify the waypoint. For namespace though, it's the same thing. So we see here that's not already added. Go to step 2. We use istioctl to label the namespace. That's waypoint apply -- enroll namespace. You could pass in a specific namespace value. I think you would do like in addition -- namespace and then the name of the other namespace that you want to enroll it into. But if you just leave it alone, it would just be default, which is fine in this case. And as you see, we add that label, or it tells us that the label use waypoint is added. And we can actually confirm that by looking at the namespace itself, and you'll see now that the label has been included in that list of labels in the metadata there. So now that's how you enroll a waypoint for a particular namespace. Again, this is good for like, huge workloads or, things like that. You don't have to restart your cluster or anything. It's pretty convenient. It just adds in the label, and then the system knows now that that's the waypoint that should be used. And now we're to the part where we have the Ztunnel config command. And I'm actually going to pop out into my terminal real quick just to show like how that could look, and show some examples of how things might change when you're adding waypoints. But essentially, Ztunnel config was a part of another command called proxy config. Not sure if everyone here is familiar with that, but you can go check it out. It's istioctl proxy config. I don't know if it's experimental or not, but that command had a Ztunnel config option within it. But when we went to release ambient beta, it was discussed and decided that we should separate Ztunnel config out into its own thing. With the thought being that it's like its own proxy configuration and like logically in a sense, and also in the code, it was just easier to separate things out and break it up in that way, and also makes it more extensible. So I'll talk a little bit in the next few slides about how like generally you can go about adding new commands and the thought process behind it. But that was a pretty interesting thing to work on because it was so like coupled together, the Ztunnel config logic with proxy config, that it was a little bit tricky initially to try to take that all out. But now it's been abstracted out. It works fine, and it's pretty convenient. As you can see, you can break it out into certificates, logging levels, I believe, for Ztunnel, the policies, services, workloads, or you can view all of it, and then you can output it to JSON or YAML, or you can just leave it as all, and I think it has like a short summary version of it essentially. So let me just unshare this real quick, and then just show a few quick commands in my terminal. Just give me a second to get that up. Did everyone see this? Is the font fine, Zila? Good? Okay. So good. All right, so yeah, so we can first just look at the gateways we have. We just have this default booking flow gateway that I added by following some documentation, but we're not going to worry about that right now. I'm just going to show mainly the Ztunnel config changes that happen. So I didn't have a slide for that. I'm going to show what happens when you don't have a waypoint and when you add one and how things look different. This is useful for when you're debugging a situation where you're doing some type of curl commands or something like that, or sending traffic to from one pod to another. Maybe you have an authorization policy set up that sets the expectation of having traffic go through a certain waypoint. You're not seeing things work properly. You would consult the Ztunnel config in some cases to see what's going on. So let's create a waypoint right now. We'll do generate just to see what it looks like and make sure it looks fine. And then just do it like that. So as you can see, specify the all traffic type, the name. If I were to just do some gibberish, that's the valid options message that I was talking about earlier. It's going to tell you that it's invalid. So that's pretty convenient. Once we decide that we like that, we actually, and there's another thing we could do. We can actually look at the namespace real quick. Just confirm that there's no use waypoint label. Then when we go to apply this, I'll first apply it without doing a role namespace so you see what it looks like. So we do that. There's not going to be any use waypoint label. If I do that's the tunnel config. You can also do ZC. Yeah, if I do workloads, for example, you're not going to see the waypoint there. I can go in and manually add use waypoint value to these different like pods in this case, but it's not gonna show for every single one if I expect it to without actually adding an enroll namespace. And same thing for services, right? And we know that we have a waypoint that accepts all traffic, so you would think that Ztunnel would recognize that, but you have to enroll it to the namespace for it to work. So we'll do this. We'll see that the use waypoint label is added, right? And then we'll also see now that Ztunnel sees that that's the waypoint that's expected for that namespace. Now, if you look at services, same thing. Yeah, so that's, and then I guess I could show one more thing too, actually. There's the gateways. You can just describe the gateway. You can see that the waypoint for label is also added there as well. Yeah, pretty basic stuff. It can be very useful though. When you need to debug issues or troubleshoot problems you might have. And if you're wondering like, why is the traffic not going through the waypoint that I expect or whatever, you can just do some sanity checks with Ztunnel config to just make sure everything's labeled as it should be. Check the gateway, check the maybe you want to overwrite what the use waypoint value is and you want to add it for a specific pod. You've already previously added it for the entire namespace. You go check and you see that it hasn't been updated yet. Make sure that that pod has the right value. Those are the kind of situations you want to check that for. And now I'm going to share one more slide. It's about like contributing, which I think is pretty useful. See that, right? Yeah, so this is like a screenshot of some of the contributions I did to istioctl right around the ambient beta push. And this is a lot of the work that I did to actually get to become a maintainer, user experience focused. was working a lot on this stuff. Now, there's like 5 high level, I guess, steps you can kind of think of when you want to contribute to istioctl and do it successfully. And then I'll go into more detail about the nuance of like how some things got decided. So, in general, you want to get consensus on what you or why there's a need for a command. There's plenty of times where, the need for a command might come up in a conversation on a PR somewhere else, or someone's using the command and realize like, hey, this isn't actually a good user experience. We need to actually add this piece or whatever. And you kind of just iterate on it. But in order to do that, you have to get the consensus. So you come up with a reason for why something's needed. You share it with the community through an issue, or sometimes it can just be through Slack. Ideally, it would be an issue though. But pretty often we will talk on like ambient dev in the open. It'd be like 80 comments on one thread, like hashing over an idea for a command or some change. But you got to get everyone to basically agree on it. That will speed up the chance of getting the PR in. And then once you actually get into the code for istioctl specifically, a lot of it is just making sure that you register your command, your sub command with Cobra. Cobra is a library that is used in Go to write CLI tools. If you look at like the Cobra examples and look at how istioctl is used in Istio, they look pretty like similar and straightforward. You make sure you register the command in the right scope. Is it a sub command? Is it higher up in the command hierarchy? Like sometimes there'll be discussion around whether or not, like, for example, the traffic type. Does it make sense for it to be like for waypoint, like the istioctl waypoint command, or did it make more sense for it to be under istioctl waypoint apply? And in that case, it made more sense to be under the apply subcommand. And then you really just add in a flag at that point. Those are the kind of things you want to make sure it makes sense. Once you figure that out, then you want to make sure that you're sanitizing inputs, checking for errors. Pretty straightforward, like, Go or just programming stuff in general. But you want to be especially careful because you don't want like no panic type issues that you might encounter when using like Go and in the Kubernetes client. You're checking for an object that you assume has some information, and through some test iteration somewhere, that object doesn't exist and you didn't account for it, and now you get in a panic. So you got to make sure you're paying special attention to does it exist? Am I overwriting something? I've done that before. I made a PR where I think I was like overwriting labels or something like that. I don't know if Ian is on the call if he remembers, but I was working on it, couldn't figure out why it wasn't working. And then I narrowed it down to I was overwriting the labels, and yeah, you don't want to do that. You want to just, if there's labels that exist, for example, you want to add to it. If it doesn't exist, make the object so that you're not trying to write to a null thing. That kind of stuff. And then make sure you're updating the necessary resources. Again, that will kind of come with the consensus if you talk about it enough and have a good idea of what you want to add. What resources need to be updated are pretty obvious at that point, but be clear on that. And then, yeah, you test commands, you iterate and promote from experimental to stable when it makes sense. A few comments about that. Testing commands. Even just doing this demo, I was testing stuff. There's plenty of times where like I use istioctl a lot to just do dev work. Operating Istio is something I want to get better at and do more work on. A lot of my Istio experience is like contributing to the project and then using tools around that experience. So if I'm trying to use istioctl to confirm something while I'm developing a feature, there might be times where I encounter like an issue with istioctl itself. I'm like, hey, that's kind of weird. And then I'll share my experience in the chat, and someone might pop up and say like, oh yeah, that actually was broken because of this. And then I'll go and make a PR to try and fix that or improve that experience. Testing commands will often generate more work. I think that's a good thing, but maybe some people might not want that. But if you want to make more PRs, it's an easy way to get issues or reasons to make PRs. Test the commands and see how they work and try to find the issues with them. And then, yeah, iterate. If you notice that screenshot, a lot of these changes, they're like little changes that stack on each other, right? Or they're like changes in how we think the system should behave. One notable one is at the very bottom, you see things like annotate service. We actually decided a little bit up that list that we're gonna switch from annotations to labels. And that's just like, like a design decision that kind of happened like midway through. We already added some changes to istioctl, and and also behind the scenes with a lot of the traffic related stuff that Ian was working on. And we decided that labels made more sense than annotation. So then we had to make PRs to adjust for that. And you'll see this a lot when you're working in alpha or beta, especially in open source, like code is moving fast, design is changing sometimes quickly and sometimes much more different than what was initially expected for the scope of the work at the start of it, right? It's going to change over time as people use it and understand that a user experience better, which is pretty interesting. And then the promotion bit, I think actually John Howard, he noticed that there was a good amount of usage with Ztunnel config and waypoint that it didn't make sense necessarily for them to be experimental anymore. And then he went ahead and promoted those commands, which also involves documentation changes. So once we, I guess once we have 1.23 out, I think they will be considered promoted at that point. We'll have to ensure that all the documentation reflects that, and you just go through the code and update things accordingly. Again, more opportunities for people to contribute. But most importantly, I really want to highlight that people should feel empowered to, if they see problems with Istio while they're using it, to let us know. Don't be scared to make issues, go into Slack, ask questions. I think a lot of the istioctl work actually that I would end up working on was a result of like a customer issue or a contributor or maintainer finding it on their own, and then we just iterate based on that. So, the more feedback we get, the better, the faster we can actually improve on things, the faster things can be caught. Sometimes I feel like there's always the chance, right, of being in like this siloed kind of situation as a contributor where you're in the code, you're working on it, and maybe you're getting kind of far off from what the users actually want. You want to avoid that. So the more feedback we get from users, the better. The more issues, the better. Yeah, and feel free to tag me on any of those or any of the other maintainers. I work I'm an Istio maintainer for user experience, so anything related to that, definitely you can add me personally or just check off the user experience box when you go to create an issue, and I will get pinged on it. And then issues can just be discussions too. They don't have to necessarily be an issue that has to warrant a certain amount of work. So however you want to get that information across, issues or Slack channel, whatever makes sense. We also have community meeting times too. So I think if people attend those and give their feedback, it'd be also helpful. Yeah, so yeah, that's it for me. Any questions?
Thank you, Jeremy, for the nice presentation. Yeah, it is really nice, just simple comments, but I think they're really useful. And I especially like that one of those last slides where you were focusing on the need for iterating over the commands and promoting from experimental to stable. Many people just contribute certain things and put it in experimental mode and leave it there, and we won't see them later to, move it to the next stage. It's really nice to see a lot of hard work from the folks from Microsoft. I know that many of you are working on the enhancement subgroup and then trying to make sure many of the features are moving to the stable state. Thanks a lot for all those great work all of you do. Let's see if anybody has any questions. Maybe for 1 minute, we can just see. Yes, Bernard, then I think you can get started with your self-intro, and then
Okay,
all
great.
I would do here.
Thanks for having me, Priscilla. Appreciate it.
Thank you, Jeremy.
Yeah, thanks, Jeremy. That was a great talk. So I'm going to talk about something else today, which is more on the user side. So let me share my slides. There we go.
Jeremy is a user experience maintainer as well.
Great.
So what we are going to share might be good inputs for him as well. Yeah. yeah, for Istio.
Perfect. Can you see my slides? Yes.
Yeah.
Okay. So I'm Bernard Van De Walle. I'm the lead for the Istio traffic engineering team at Splunk, and I'm here today with a bunch of my colleagues. Some of them that actually built what you're going to talk about today, like Nils. So thanks to them for joining as well. And yeah, essentially, to give you a bit of context, we talked about this before at IstioCon, but we build Splunk Cloud. Splunk Cloud is essentially, you can see it as a cloud native Splunk, which is partially running on Kubernetes. So we manage around 40 plus clusters. In AWS, we used to build them on KOps. Now we are moving to EKS, and on Azure as well. We're actually building quite a lot of AKS clusters right now. And so on top of all of those, we essentially deploy Istio. Today, it's in the mode in which each cluster got a single Istio control plane per cluster. And we use Istio to manage our edge gateways, to manage compliance to MTLS. We do some traffic engineering like circuit breaking and all the usual stuff. And we also really value the metrics, the observability we get out of it. So I really invite you to watch the talk we did a couple of, I think 1 or 2 years ago, on how we install, maintain, upgrade Istio at Splunk, and the issues we are having with it, mainly from the user side. So some of the stuff that we touched on during that talk was, as a lot of service teams or infrastructure teams, we spend a lot of time helping end users with fiber trees, typically from the gateway. So that's basically hand-on debugging, trying to understand why things don't work. And the other things we spend a lot of time on is helping end users or service team to expose a service to the outside world, right? So typically they got a pod, they want to expose it, have a public domain or DNS on which they can get to their API, right? So if you want to do this on Istio, the issue is you need to understand Kubernetes, you need to understand the deployment, the service, network policies if you use them. And on top of this, you also need to understand Istio. You need to understand a virtual service. You need to understand how the gateway CRD works and how it selects the correct gateway pods. You need to understand destination rules, service entries, and all of those complex CRDs. We also use peer authentication and a couple of others. So you also need to understand DNS management to some level, at least if you need to configure DNS, and certificate management if you terminate TLS on your gateway. So all of this brings a lot of complex configuration, a lot of cognitive overload for service owners that honestly have other things to do than configuring Istio and Kubernetes. They need to deploy their service. That's what they want to do. And so I love this picture. I'm not sure where it comes from. I think it comes from the Istio or the solo.io blog, maybe. So thanks to them because it fully encapsulates, to me, the complexity around exposing an application on Istio and Kubernetes. So what we decided to do at Splunk is to build a service abstraction layer that we call gateway router. So what it is, it's essentially a control plane abstraction that will expose your service end-to-end, but also a data plane that will allow you to do some checks on the edge, on the gateway directly. So the control plane is essentially a controller, and the data plane side of this is more like an API gateway that will validate some of your headers, some of your methods, hosts, and so on. So the goal of this abstraction, this gateway router, is to create a golden path abstraction layer for, let's say, 80% of the use cases. And the goal behind it is to have a single layer that will manage all of the Istio objects for service owners, things like virtual services, destination rules, gateway service entries. It will also fully manage certificates, DNS management, network policies. So really the goal is if you follow that golden path, it's to have it fully configure everything on the infrastructure for your service to be able to be exposed in one click almost. And so the use cases we had was we have a bunch of NLBs which are tied to a DNS name Those NLBs then go to an Istio Envoy gateway on the edge. That Istio Envoy gateway manage one or more domains. And what we want to do is we want to multiplex those domains and allow multiple services to be hidden behind that domain. And so we want to be able to do path routing essentially on the gateway and to go to different services, like in this case, service A, service B. And we want to be able to manage multiple domains, so multiple NLBs with multiple gateways. And each of those domains might are configured on different gateways typically. So how did we do this? Well, we essentially built a controller around services. So our controller will scrape services and look for Splunk annotations that we defined. Those Splunk annotations will indicate to a gateway router, to the controller, that this is a service that we want to expose publicly. And those annotations will define things like what's the internal name, the external name, the versions that we support, and so on. So it's essentially an opt-in model in which service owners can add those annotations at any time. The controller will see it, will scrape it, and do all the hard work behind the scene. So one of the key things we did was to ask our service users to provision an OpenAPI file, an OpenAPI spec file. So for those of you that don't know OpenAPI, it's an easy way to define all of the methods or all of the API endpoints that a service can handle. And it allows you to put things like, is an authentication required? Or what's the expected method on that API endpoint, that kind of stuff. And so each service owner created that OpenAPI file and put it through a standard library into a canonical place. Like in this case, it's service info specs. You can version it. And the goal is for the controller to be able to scrape this. So as soon as you add the annotation, so those annotations, the abstraction layer controller, gateway router, is going to attempt to scrape those OpenAPI specs on your service. So this is the bigger picture. You got your service, you got some annotations, gateway router will scrape those based on those annotations, and then you got your deployment, you got your pods, and embedded into your pod, you have like an HTTP server that will serve those OpenAPI specs. Again, we created actually a standard lib that users can import and that will automatically create an HTTP server and expose those OpenAPI specs so that it's a very easy one-line almost thing to do for end users. So what does it do? So once you scrape those OpenAPI specs, gateway router will essentially translate them into a virtual service CRD and only expose the allowed methods and paths, right? So the virtual service CRD will essentially be tailored to those OpenAPI specs, which allows us on the edge gateway to directly drop methods or requests that don't match one of the methods into the OpenAPI specs. It will also create the destination rules. I'm not going in detail here, but we can do more complex things around blue-green deployments. It will also configure network policies and so on. And essentially, the key thing is it will connect automatically to the correct gateway based on the hostname that you want to expose it on. And those gateways will be pre-configured with a certificate and with DNS fully set up. So one of the things we can do through this controller is manage multiple versions. So this means service owners in the backend can upgrade their service and expose different versions. And if you don't specify a version, you will go to the recommended version by default. The other thing we handle through this controller is we got an external name, which is the public name of your service. And then we got an internal name. And this allows us to do path rewrite, for example, on the gateway directly. And this allows us, for example, to keep an external name, but to change the name of the services internally. Essentially, it allows us to have a vanity path or request name. Okay, so that was for the control plane side. all those last slides were essentially explaining how we configure things on Istio. But gateway router is also an API gateway. So we use it on the data plane for each request coming into our gateways as well. So the way we do this is we use Xtozi, Xtozi being that upstream Envoy protocol that allows us to synchronously, for each request hitting the gateway, to go to gateway router and ask gateway router if that request is essentially allowed or denied, right? And so gateway router being a controller itself, it really got a lot of information about things that are allowed on the mesh, which are the path method requests that we want to allow to our upstream pods. Essentially, we decided to augment that with some other things, like we also want to check on the edge our authentication headers, and we support a bunch of them, typically JWTs. We also need for requirements, for a compliance requirement to check ITAR compliance stuff, which I believe, and don't quote me on this, that it's based on the source IP that need to come from countries that we are allowed to do trade with to some level. And we also support a centralized quota that gateway router handle through Redis. So essentially, whenever you have a request coming into the gateway, it will go to that Xtozi protocol that will then go to gateway router that will run through all of those checks. And at the end of the day, gateway router will allow or deny the request, right? So on top of what the virtual service CRD will allow through those tailored path and method checks, gateway router will do those extra checks based on authentication on the edge, ITAR, centralized quota. And the goal is essentially to do this on the edge, to not use network resources to go to the upstream pod, and so that each upstream pod doesn't have to redo those things. Okay, so one of the things that we learned is once you deploy a controller like this, an abstraction layer, you also need to provide observability. If not, your end users will not know if it works correctly or not. So we expose a bunch of debugging endpoints that allow you to see what works and what doesn't. For example, this is our main debugging screen that allows you to see if your service is exposed, what's the internal name, external name, the status of the last scrape. So for example, on this one, you can see that the last scrape was not successful because of a 500 HTTP error. We also expose a ton of control plane metrics, around scraping, how many services we got exposed on which gateway and so on. We got a ton of dashboards around this. We also got a lot of data plane metrics, obviously, around accepted requests. Those complement perfectly what we get from Istio. So together we build a ton of dashboards as well around our data plane. Finally, let me close with what we learned. So essentially, when you build an abstraction layer, I think the easy thing to do is to try to solve all the use cases. What we try to do is to figure out the 80% that we can solve well, that will basically give us the most bangs for the bucks, right? And solve those, right? For us, that meant exposing services and managing virtual services, destination rules, and so on. I think it's perfectly fine to tell some service owners that they don't fit into that model and that they're still on their own, that they need to configure those things themselves. The other thing is your service abstraction essentially embeds the culture of your engineering teams. I think what you will end up building is very specific to your teams and to your history and to your culture to some level. So it makes it also very difficult to open source. I mean, we've been talking about it, but there is so many Splunk specific things into that abstraction layer that it's very difficult to apply generically. And the other thing is, once something makes it into abstraction layer, it's very difficult to remove it because people rely on it. So you need to be really thoughtful about what you put in. The last point is maybe the most critical. People will have some friction, or service teams will have some friction to be onboarded into that layer. So you need to work with them, talk with them, try to help them getting into that model. And once they see the value in it, they will continue maintaining it to some level. Okay, I think that's pretty much it. I need to close with a mandatory we are hiring, I think both for Istio team and Kubernetes teams. And yeah, I want to also say thanks to my team that's here with me today and to Niels that built a lot of this. He's also on the call.
Thank you so much, Bernard. Yeah, it was a nice session. Yes, I was about to ask why don't you people open source some of this, and then you already answered that part. But I assume these are great inputs for our user experience team to understand what can be made better, so that yeah, users like you can make better use of Istio.
Yeah, I mean, it's a really good point. We've been talking about open sourcing it. People have been reaching out because we presented some of it at IstioCon. The issue is, again, we have so much Splunk specific things that, I mean, honestly, it will take a lot of resources to make it generic. It's possible. It's just very time consuming, I think. I personally would love to do it, to give back to the community. But yeah, it's also dubious if other people will have the same need as us, as they will need to embed some of their own culture and ways of doing.
But if there are certain specific items which you think are like doable for the upstream community, maybe you can even raise the issues and see and tag the user experience team and see if we have some other resources for interested in
Okay.
doing.
Yeah, that's a good point.
Anybody has any questions? I think somebody has asked, where can we find these slides? The slides, yeah, we can share it.
Yeah, I can share a PDF of this after, for sure.
Any other questions? Jeremy, you have any questions?
No questions from me. Yeah, good presentation, Bernard. It's nice.
Thanks. Same to you.
Okay, then I will stop the recording now.